Hello and welcome to today's webinar from BRUKER and RETSCH about enhancing quality control in food and feed production. Today here with me is Andreas Niemöller, and later also we have from RETSCH Gerhard Beckers. So let's have a look at our agenda for today. So we'll first start with a little bit of an overview of the analytical methods, so FT-NIR and XRF. Then we will switch over to Mr. Beckers for an overview of the preparation techniques. We'll then go to the lab and he will show you the laboratory equipment for sample preparation. Then we'll show our devices, so FT-NIR spectrometers and XRF spectrometers. And last but not least, we'll also have a Q&A session. So now take it off, Andreas, for the first part.
Yeah, thank you, Adrian. So I will just first introduce BRUKER. So BRUKER is a worldwide operating company, and BRUKER was founded in 1960 in Germany by Professor Laukin. And maybe good to know that even one of his sons is still our CEO. So it's still a kind of family business, but we are listed in the Nasdaq, so we are on the stock exchange. And BRUKER is well known in the analytical business and a big player here. And we have worldwide representatives, and we are very innovative. So you see a lot of our revenue is going to innovation. And let's have a look on the structure of BRUKER, and mainly the divisions, of course. So I start on the right upper side. So BRUKER Biospin is the biggest entity of BRUKER and was a starting point at BRUKER in 1960. And in general, all kinds of entities are working with spectroscopy, and the Biospin is working with magnetic resonance. And it's falling clockwise, so the BRUKER XS, where Adrian is part of it, deals with all kinds of XRF and XRD spectrometry and elemental analysis in general.
Correct.
Then we have the BRUKER Daltonics, which is based on all technologies in mass spectroscopy. And finally, I'm representing BRUKER Optics, and BRUKER Optics is dealing with vibrational spectroscopy, namely infrared, near-infrared, and Raman, including microscopy technologies. So what is spectroscopy all about? It's all about radiation, and when we look on the two technologies we are introducing today, so we have XRF with the higher energies, dealing with the atoms or the inner electrons and elemental analysis. And on the other hand, on the other side of the visible range, we have the near-infrared. And near-infrared is part of the infrared range, but it's a special part because it's near to the visible, so that's why it's called near-infrared. But it can measure through glass, and it can measure big samples, with what we will see in a minute. So let's follow how NIR spectra look like. Just to give you an introduction to how they can look like. So you see in blue is a spectrum of a raw meat, which has a lot of water inside. Or we have, in contrast, we have an edible oil here in black. And in between we have the rapeseed and the fish meal, and you can see in the different parts of the spectrum all the different informations about protein, fat, carbohydrates, and so on. And in general, we can measure all which is organic. And this is based on molecules which contain CH, NH, or OH, which are always present in this kind of molecules.
Yes. Yeah.
So that's why NIR is very versatile for anything which is organic. Okay, so what can we do with NIR? So the main topic is quantification for the quality control, what we will see later on in examples. You can even do some identification. And you can even do some screening, because NIR is a very fast method. It's not so specific as NMR or mass spec, but can do a kind of screening to see if something is unusual. Okay, the main topic of today is even to show how we can measure the samples. And as I said, NIR is very easy because you really don't have to prepare the samples. Okay, we will show the grinding today, and we can measure with NIR liquids, solids, and semi-solids. And depending on what we want to measure, we may use different technologies. So on the left side, you see the transmission for liquids. And now you see that it's very easy because we can use a glass vial
Yeah.
for an edible oil, or we can even use a cuvette for beverages or milk or whatever. And here we measure in transmission, so we measure through the sample.
Okay, yeah.
The other main part of NIR applications is done in reflection. So this is for all kind of solids, granules, seeds, whatever you have.
So including feed, yeah.
Including feed, yeah, we will see. And when we look on food, yeah, you can see that it's could be all kind of samples like meat, cheese, chocolate, sugar, whatever, and including oil seeds, feed, and so on. So it's very versatile. And in case that you have samples which are either not liquid or not a real solid, you can have difficulties to measure them. So we can measure special samples like ketchup or molasses or viscous samples. We can measure in transflection. So here we make just a drop in the vial, enter a mirror, and we can still use reflection, but it's basically the light is going onto the mirror, coming back, and by this you can measure even a liquid.
So through a little bit of sample, yeah.
Yes.
Yeah.
So let's see how you do XRF.
Yeah, thank you, Andreas. So just a few principles here. So with XRF, we have an X-ray source, an X-ray tube that excites the sample. And so once that's done, you have in the sample some interaction. So we kick out inner shell electrons. That's in this way, we are sort of independent from the next neighbor, from the bonding part. So that's also why it's a pretty flexible method, can deal with all kinds of samples. So what happens next is an outer shell electron falls into the vacancy, and then characteristic X-rays are emitted. So these are characteristic for the atom and for the transition. So you have different transitions here, K beta, K alpha. And then we have a detector. There can be different styles of detectors and different technologies. That's a bit too much. So here you have also the video to online where you can learn a little bit more. But bottom line is that we have a detector that counts the incoming photons and also differentiates in an energy dispersive world by either by their wavelengths or by their energy. And this is then, these counts and the energy or wavelengths are then proportional to the concentrations in the samples. And that's how we can get sample concentrations, elemental concentrations. Yeah.
Okay.
So what can we do with XRF? Just briefly speaking, the typical feed and food analyzer would be an energy dispersive system, like here the S2 Puma. We have also a benchtop system, the wavelength dispersive system, the S6 Jaguar. In some cases, that can be the better fit. So we can analyze all kinds of samples as shown there in the loader on the right-hand side of the slide, upper right-hand side. So loose powders, liquids, pellets, solids, and so on. We can measure essentially from fluorine up to uranium, can quantify all these elements in all the samples that you can think about. And this on the concentration level, this means typically macro, micro, mineral nutritions, but also trace element contaminants. Sample preparation and sample handling is relatively straightforward, but this will be a big topic of today's presentation and today's webinar. So let's go into that a little later. Time to result, including sample preparation, is about 5 to 15 minutes. Yeah.
Cool, okay.
So the big benefit of XRF versus other technologies, that's namely elemental analysis technologies like ICP, OES, or AAS, is essentially that you need no acid digestion, especially for solid samples, powder samples, and also no dilution. So this makes it really easy to use. You have the sample. We'll go over the sample preparation later. You have also no hazardous or expensive chemicals, and it's especially useful in the production environment where overall the time to result is shorter because we don't have the heating up part. We don't recalibrate also. So the system is once calibrated. You can run this calibration almost forever. You can update the calibration at some point, but essentially you can run it 24/7. So this is the big difference to alternative methods and really allows it to be an excellent tool for production environments.
You can use the same sample for NIR, as we said already. Yeah?
Exactly, yeah. Yeah. So the same sample that is measured on the NIR devices can be also measured on the S2 Puma. Yeah. In terms of methods or solutions, so to speak, there are essentially two different approaches. The one is so-called standardless. There we have our smart quant solution, which is based on full fundamental parameter approach, where we do forward modeling of the complete spectrum. This allows us to be completely independent of the sample material, sample type, and essentially measure complete unknowns. Of course, this has some limitations in terms of precision and accuracy, and the more information you provide about the sample, the more accurate it gets. So for example, if you want to measure some minor constituents rather, or major ones, but you know that the matrix is so-and-so, you define the matrix and it helps you with the results. So this is mostly used for sample screening, quick screening, raw material identification. Mostly in a production environment, we will calibrate. And here I just want to briefly walk you through how such a calibration could look like. So here I simply took 8 reference material from round robins and BPA and AFCO samples from a pig feed. I pressed them into pellets. You can see that in the image up right here. I included 12 elements, and I run a calibration. So let's take a look at how this works. So this is the interface in our software. So you don't need to be scared about calibration because the software really smoothly walks you through the process. You type in your values, you run the samples, you define maybe the counting times and so on. You already get in a sense about the determination limits and so on. There are overlaps in the spectrum, but the software will essentially provide you all the necessary settings automatically. Fine tweaks are done by experts, but this is typically not needed in the feed environment. So it's really easy to use software. Once the method is deployed, it's just press a button and analyze. Yeah, we will show you later. Just for the sake of completeness, here's a repeatability test with a pig feed. What we often get as a question is what is the precision of this analysis? Honestly speaking, precision and accuracy can be as good as for most elements and most concentrations as ICP as the reference method. That's the bottom line here. And we go down to sodium and even fluorine in some cases. And we, of course, also cover the high-risk ingredients, which can be copper, zinc, manganese, for example, in the feed materials. So now let's have a closer look at the comparison of the different technologies. And here we will start with food. So we will walk you through some examples here. Especially food is a gigantic market, of course. It's a gigantic, you're dealing with a lot of different materials. So here, this is just providing you an example. So with XRF in food materials, like, for example, cacao, rice, but also meat and flour, for example, we would do things like raw material ID. So we look at really sodium chloride. We look at some nutritions like calcium, manganese, for example, iron. We look at salt content. We also take a look at the heavy trace element contaminants. And last but not least important is that we also do, that's more done with handheld devices, foreign body identification. And now maybe, Andreas, you can tell us a bit more about what FT-NIR does in the food world.
Yeah, thanks again. And as I said, we are looking on all kind of organic ingredients, organic parts of the sample. And the most general parameters are, of course, fat, protein, moisture, and ash in food. Ash is not an organic ingredient, but we can, even when it's not organic, we can measure it or calibrate it. But depending, when you look on the different food samples like meat, grains, chocolate, condiments, and so on, we have even other parameters like starch, sugar, alcohol, density, pH, and so on. So depending on the food stuff you want to analyze, there are always special parameters we can cover with NIR. And so it's a wide range, and BRUKER is even providing pre-calibrated instruments for such major products. And now switching to the next topic, a very important industry for us is dairy, which is a special part of the food industry, of course. And here we have basically the same parameters in NIR, so fat, protein, and total solids or dry matter, and for example lactose as a standard. And here again, we can measure from raw milk up to all kind of standardized milk and maybe the milk derivatives, liquids, over premixes to all kind of solids and semi-solids, powders, milk powder, whey protein concentrate powder, cheese, yogurt, and so on. even infant formula, which will be important for you. But last but not least, we can even measure all kind of plant-based substitutes. So plant-based products are a big market nowadays. So this could be covered as well by NIR. But so let's look on the XRF element analysis in dairy.
Yeah, so in dairy, and you already named it, one of the most important applications is infant formula. Essentially in various powder products, so maybe lactose, milk powder, but also infant formula, we're looking at the mineral nutritions again, at the ratios, but also heavy element contaminants. The nice thing here is, again, we can essentially use the same sample. No? So we can use the same sample on both devices. The applications, as Andreas said, are quite a bit broader on the FT-NIR side, but there's also various use cases on the XRF side. A bit more recently came up also salt content and calcium content in vegan cheese, for example, which is not directly dairy, but sort of related. Let's maybe take a look at the next application here. So another one that we picked for today is seeds, oil seeds, and oil refinery products. So here with XRF, we are typically looking at a little shorter number of elements. So the most important elements are here really phosphorus, sulfur, and chlorine. Phosphorus is maybe the most important part in edible oils. So here we can really go to sub-ppm levels, very high repeatability. We do this with a polarized equipment, with the S2 in this case. And this is as a monitoring tool at edible oil refineries used for phospholipids removal process, which is, for example, important for the shelf lifetime. A little bit related to this is, for example, the turning oils into biofuels, used cooking oils. Then you also have the applications of looking into sulfur, for example, and chlorine. But we can also monitor other elements. So it's the same kind of story. So if you're interested, some are interested in magnesium or potassium, that can also be done with our equipment. How about NIR?
NIR is covering the whole chain, from the oil seeds over the refinery until the final products. And it's the same story again, fat, protein, fiber ash, and moisture, of course. In the oil seeds, we have sometimes uric acid or hyaluronic acid analysis in the seeds already, which is good when you start the refining process. And later on the edible oil side, we can measure already the crude oil, and later on even the finally refined oil. And here we cover a broad range of parameters, including the complete fatty acid profile, which is later on very important for companies who are using oil in the food industry, that they can see if the oil is good and it's the quality they want. And for the quality, we can measure the free fatty acids, we can measure the peroxide value, we can measure the iodine value, we can measure the moisture content. So it's really, in seconds, we can do a quite nice quality control of the oils later on, everywhere in the food chain. And in the edible oil business, sometimes the biodiesel is even important. That oil is, or used oil is used for fuel analysis. And here NIR is doing the same for all kind of relevant parameters. And finally, we switch to the feed business. And feed is, again, same parameters, moisture, fat, protein, where you use it to measure all the ingredients, and based on what you get as ingredients, you make a formulation. So it's very important to save some money and to not spend money on not ingredients you don't want to have. And we can do even process monitoring. We can measure the final feeds, of course. There are even special feed services measuring amino acids for the digestibility and so on. So the feed business is a very important business for us. And it's just covering even all the agriculture samples, which you cover with the XRF as well, right?
Yeah, right. So from the XRF side, I would also say that the animal feed part is maybe the most important market and application. Here we really cover with XRF everything from the raw material to the final feed, and then even the system is used to provide feedback to the farmers. So they use it to measure even the urine and feces with XRF to see how, if you need some dietary changes. So this goes then a little bit also more into customer support or R&D parts. But the most important parts are really looking into premixes, looking into TMR, looking into final feed with XRF. And here we cover all the major mineral and minor, macro and minor ingredients. And that's also where our S2 Puma is really a nice feature for this market, and that's what we will show a little bit later. So maybe let's switch to the summary. So overall, we've seen that in food and feed with FT-NIR and XRF, we can cover almost any sample type. We will see in a bit that we can use the samples on both devices. Sample handling is pretty much straightforward. But now we want to see also what do we maybe have to do to the sample before it gets analyzed. And this gets us back to Mr. Gerhard Beckers, who will show us a little bit about the RETSCH devices to prepare samples for XRF and FT-NIR analysis.
Thank you, Adrian, for introducing. I would like to take the opportunity to introduce myself and the company RETSCH. We are part of Werder, and RETSCH is a manufacturer of mills, test sieves, and sieving machines for almost any kind of application. With our experience of more than 110 years, we are able to offer solutions for almost any kind of industry related with the analysis and the research and development of solids that you have to prepare in front. I would like to tell you something about the sample preparation of solid materials. And as you have seen, there's a lot of possibilities to analyze the samples, but before you analyze samples, you have to prepare them to get a correct and reproducible result. When you take a look at a sample like this here, it's just wheat, and it's easy to analyze the sample from its outer appearance, and you get a quite simple result. For example, when you take a look at the fiber content. But just looking at the surface of the wheat, you can see that you get a complete different result when you do this with a ground wheat, as you can see here. So you get two different results. First of all, with a wheat from its outer appearance, you just get a very high fiber content, but when you grind the sample to a fine powder, you also take care of the inner parts. So the fiber content is decreasing extremely. And another point is, as you can see here, the standard deviation between all these measurements completely decreases when you have a very fine powder, and you can create a reproducible result, undependent on how many samples you analyze at the end. So the idea of preparing a sample is to create a good fineness, to have a reproducible result and a homogeneous result, and to take care that the small sample that you use for your analysis is representing the entire amount of your material. But when we talk about preparing a sample, it is very important what you have to consider in front. So this is not just the grinding principles which you have to take care of. You have to choose the correct mill, and sometimes the sample has to be prepared in front. And last but not least, the process parameters have to be considered. And this is a lot of stuff which has to be combined to create a good result at the end. And this is not just science. There's a lot of also creativity which needs to be taken into account to get a good result at the end. And this is what we offer as a solution, that we not just offer units, we also offer experience for your application that you can create a good result at the end for proper analysis. I would like to take care now to explain what we're doing. Grinding means we have to mechanically prepare the sample. And for this mechanical preparation, you've got 5 principles on hand, or mechanisms on hand, how you can grind the sample down to smaller particles. One of these principles is the pressure, so you just press the samples until it bursts into pieces. Another mechanism is impact. That means the particle is bashing against the wall, or a grinding tool is bashing against the particle, and then it can be ground into smaller particles. Another principle is the friction. That means it's just ground by friction, and the particles are just taken off of the big piece. Another principle, and these three in the beginning are mostly principles for hard and brittle samples. Another principle is shearing, where you just push the sample along a sieve, and then the smaller particles shear off, and so you can grind it down to smaller pieces. Last but not least, cutting. Like a knife shown here is just cutting through the particle, or two knives are cutting the piece into particle into smaller pieces. And these are principles which are normally used for the soft and elastic materials. But all these principles are combined in a way in our machines. So we have got 5 principles, but we have lots of mills that can deal with these principles to grind the samples down to a suitable fineness for your application. And so we've got mills for hard and brittle samples, like a jaw crusher here. This is just one of the machines. We've got plenty of different machines. A jaw crusher for hard and brittle materials, which is grinding by pressure. We've got hammer mills, so a hammer is bashing against the sample. This is grinding by impact. A similar principles with a rotor mill, the so-called cross beater mill, that can also grind the samples down to finer particles by impacting. Then we've got the machines which create a finer result, like planetary ball mills. These machines can grind down to micro and nanometer scale size. This is also for research and development very interesting. Or you can use vibratory disc mills, very often used for the XRF industry. And the mortar grinder is a very famous, or very old-fashioned machine, I must say, but this is a machine where RETSCH started with in 1923. On the other hand, we've got the soft and elastic samples, and for these samples you can use so-called cutting mills. So we've got the knife and the rotor, a rotor and a starter, and then knife is cutting the particles into pieces. Another machine which is very frequently used is a mixer mill for smaller sample amounts. And this is a ball mill which grinds the sample by impacting, so the ball is impacting against the sample. Or you can use a knife mill, which is frequently used for just feed and food samples, because it also can deal with fatty samples, with humid samples, so like cheese, bacon, or groceries, tomatoes, salad, or whatever. That's the important point, because it can handle all these oily and humid stuff, where all the other machines are struggling a bit with, because you normally need a very dry sample. Then we've got rotor mills like a cross beater mill or the ultracentrifugal mill ZM300. These are always grinding by shearing, and they also can grind bigger sample amounts as they work in a continuous mode, like a jaw crusher and the cutting mill. And here you can see a new machine, the new cutting mill SM50, which is brand new, which is a tabletop cutting mill. So this can grind smaller amounts, but it's also very versatile for any kind of other applications. So these are just some examples of machines that we offer for sample preparation. And I would like now to point out a bit more about what we can do with this machine. So showing you some examples. Here are some application examples of standard samples, like here in this case a dairy powder, which had to be prepared for XRF analysis. And as you can see here in the upper picture, we have pressed the pellet of this powder from the entire sample, and as you can see, it's quite inhomogeneous. But when you see at the bottom, there's another pellet and close up. And this is the pellet which has been created after we have ground the sample, the dairy powder, with a ball mill to a fineness of less than 100 micrometers. As you can see, the surface is very homogeneous and very even, and so you get a very good result at the end from the XRF unit. Very important, dairy powder is a very soft and elastic sample, so you have to be very careful in grinding. You need a gentle grinding procedure, so a low frequency, but it is possible to do this with a ball mill as well. Another example is like an infant formula, which has been ground for X-ray for NIR analysis. And here a sample of about 1 millimeter has been ground down to 0.25 millimeters. And this has been done in a ultracentrifugal mill. This is a machine which grinds with shearing, and the sample is just sheared along a sieve, and then it's passing the sieve, and here with a sieve of 0.3 millimeters, we can create a fineness of less than 250 micrometer. On the side, you can see the two photos of the entire sample and the ground material at the end. Another sample for the ultracentrifugal mill is, for example, chickpeas. So, yeah, any kind of grains of corn. And as you can see, this is just a small amount of sample which has been ground. So this is the same machine as before, but without the cyclone and the feeder unit. So this can be done manually directly into the machine, just 75 gram, which have been ground within 20 seconds. And here again, it's from 8 millimeters down to 500 micrometers to create a very homogeneous and even particle size distribution. Dried apples. I would like to show this also in the practical session later on. Here, this is used a knife mill, the mixer mill, the knife mill GM200, with a cutting container of polycarbonate and a knife of stainless steel. And 70 grams of this apple chips have been ground within 30 seconds below 1 millimeter. Yeah? So again, it's not just creating a very high fineness, but just to homogenize the sample in this case. Other materials like fertilizers, here again to analyze with NIR, or for other components like humidity, ash, fat fibers, and other ingredients. And here the ultracentrifugal mill, again with a cyclone separation unit and with a feeder kit is used. And to avoid the contamination with iron, we normally use stainless steel grinding accessories. We have used here titanium, and then we avoid the introduction of iron into the sample. And then we can grind about 500 grams within 60 seconds. And this is used with the cyclone separation unit, so you also can grind larger amounts of sample. In this case, we have ground the fertilizer from 5 millimeters down to 400 micrometers. So this was just a rough introduction and some examples of how to grind samples for food and feed industry. Of course, there are plenty more, and I would like you to introduce you to send us samples so we can give you some solutions for your particular application. And now it's time to switch to the lab, and I would like to show you some examples with our machines so you can see the machines working, and we've got some direct access to the machines. Thank you very much for this time, and then we go to the lab now. So here we are now in the lab. We've got 3 machines now for you to show how the grinding can take part here. I've got a knife mill, the GM200. So this is a machine which grinds a sample with a knife, that you can see here, either by impacting with the blunt side of the knife or with the sharp side. And I've prepared some apple chips, just dried apples, which I will now grind with this knife mill within less than 1 minute. The sample is placed into the grinding container, and the machine will now grind the sample with a short interval grinding so that the chips will be pre-ground by cutting, and afterwards it will run for some seconds at 10,000 RPM so that we create a hopefully very nice homogeneous result. So I will interrupt talking now because it will be very noisy, but just see what happens. So this is now just the interval grinding. The sample is just a bit pre-ground. And then it starts for a longer time at 10,000 RPM. And then the sample is completely homogenized. of course, quite dusty. So, as you can see, we now get a fine homogeneous powder, which can then be used for the analysis. This is one example of how you can grind this food material. On the middle part, I've got the mixer mill MM400. This is a ball mill which grinds the sample with a ball or one or several balls inside the grinding jar by impacting, so it's shaking the jar at a frequency of maximum 30 Hertz, and the ball is bouncing forward and backwards and is grinding the sample by impact and friction inside. Here, this is now a jar made of zirconia, which is quite useful in terms you're checking the sample also for heavy metals, so you want to avoid the introduction of iron. We all, of course, can also use stainless steel. Here is an example. I have used some fertilizer, which we will now grind with a ball mill. As fertilizer is quite soft material, we have to be very gentle in grinding, not using the highest frequency. So it's now placed into the mill. And then we start for 30 seconds at a rather low frequency. So you can see the jar is shaking. On the other side, we just have placed a dummy in, but normally you can also grind up to 2 samples at a time. So, and now you can see it's just a pink powder which comes out of the grinding at the end. So this is how the grinding can be performed with a ball mill. Of course, just one example, and up to 2 grinding stations. Last but not least, I would like to show the ultracentrifugal mill ZM300. And this machine is working based on the principle shearing. So we've got a rotor which is rotating at a maximum speed of 23,000 RPM. And there is a cassette and a sieve surrounding the rotor. And the sample is dropping in from the center, from top, and is then accelerated to the outside and ground by shearing through the sieve, and is then collected in this cassette. It also can be equipped with a continuous grinding cassette with an outlet, so you can connect it to a cyclone separation unit, so you can grind up to 3 liters in this case, and not just the 300 milliliters which can be collected in this cassette here. Here I've got a sample of feed pellets, and they will ground with the ZM300 continuous mode. As this machine is quite noisy, I won't talk during grinding. I would start it and then feed the sample continuously to the working machine. So in this case, I've used a ring sieve of 0.75 millimeters. You also can use smaller sieves or bigger sieves depending on the result you want to obtain. And here you can see this is now the result. Again, a rather nice fine powder, which then can be used for the next step for the analysis. Also, in this machine, it's possible to use different kind of grinding accessories. As mentioned in the presentation, you also can use titanium accessories so that you can grind without heavy metal contamination. So these were just some examples of what we can offer. 3 of them. Of course, there are a lot more available for you. So just ask and we will assist you in your application. So thank you very much. I would like to switch now to the BRUKER session.
Okay, hello and welcome to our next session, the practical session. So now we will show practically the XRF and the NIR. And we got a nice prepared sample from Gerhard. And we will measure it on both machines. And Adrian, you will start because it takes a little bit longer for your machine. So please go ahead.
Yeah, thank you, Andreas. So let me just open here the shutter of our XY loader. I have here put a little bit of sample material from Gerhard inside this little liquid cup or powder cup. I load it now in a spectrometer in such an easy load cup, which can be handled by the grabber. Then I can close the cover for no moment. I select the position on the touch control, where I just loaded. I select the method. Then I type in a sample name. Here we just make it 1, 2, 3. Press next, and then the material or the measurement is loaded, and I can simply start the measurement by pressing here the green button. You will now see the grabber picking up the sample, the shutter to the instrument compartment where the measurement takes place is now opened, and then the measurement is started. And so while we're waiting for the results, this takes a few minutes. Andreas can show us how to measure a sample on the FT-NIR device.
Yeah, thank you, Adrian. So first of all, I will show you more in general how to measure maybe different samples. So we have a Tango here for reflection measurement. So you see the light here, which comes up, and everything which I put on will be measured in reflection. So the light which goes away back in the instrument will be selected. And I can put in, for example, samples now in the petri dish, like meat or cheese, yeah, and put it on the instrument. And the sample will be rotating while the measurement. Or I can use another rotating device and measure with a smaller cup if I have a smaller sample size. And I can even measure some liquids. And for liquids, I can just put on an adapter. And then I can put in a liquid in a disposable vial, put in a few droplets of the oil or whatever other liquid, put in a mirror, and the mirror allows that the light goes through the sample, comes back from the mirror, back into the instrument, just put it on, measure it. So that's even possible for liquids with this instrument. But now I will fill the cup for this feed sample. So you see it's a quartz cup with a quartz window bottom. So just put it in, just enough sample that you have not light escaping. And so now put the cup on. And now in the software, I just select the product. So I selected already the pig feed sample. I can put in, as Adrian did, put in a sample description and just press measurement, and now you see the sample is rotating to get a better averaging. And it takes some seconds, of course. And then it will switch to the results, and you will see we have fat, moisture, protein, fiber, ash, and even starch as a result. So just finishing, evaluating, and now you see the list of parameters, moisture, fat, protein, fiber, ash, and even starch, and you see everything is green ticked, so everything is fine, and the results should be valid. So that was fast, and are you ready now, Adrian? Is your measurement?
Yes, I'm ready. So the measurement is completed since just a few minutes. So we can see here on the touch screen now the results. Everything is green. The measurement is marked as OK. You can remove that. Actually, on the touch screen, you can also have other information, like here in the status display. You can, for example, see what's the conditions of the instrument and so on. So the touch control is a very useful option of the system, especially for industrial environments where you always run similar methods and you just want to hit a button to start a measurement like I just showed. Now let me show you a little bit more about the system in the loader part and also its versatility. So you can see here that we have a loader with, in this case, 20 positions, and here 2 extra positions for the QC samples, for example. We have loaded different materials in this, like here another powder, just to show you a little bit. Of course, we can also measure pellets and other solids. Here's a pressed pellet from a feed material. I briefly wanted to show you that how to prepare such a cup, which I used for the powder. That's also very simple. You can take a little tool like this one, and then you place these little plastic rings on top of each other. Then they are so-called, it's polymer foils. In this case, it's Prolene. You place it on top. You press it down like this, and normally it works better. So, well, it was relatively smooth. So here you can see it should not have any wrinkles, and this is what you use then to place your powder sample, or also your liquid sample can be poured directly into this cup. And that's basically what I wanted to show today with the S2 Puma, which is really a versatile device. And I think with that we are ready to hand over to go back to the Q&A session together with Gerhard. For that, we briefly have to switch scenes and see you in a few seconds. Thank you.
Thank you.
Okay, now we are here all together for the Q&A session. Our organizer, Anja, already sorted the questions a little bit. We won't have the chance to go through all of them, but we'll also submit later on or provide later on a Q&A document, so with more questions answered. And so she sorted it a little bit by technology, so I will just, I have it here on the screen, so I will just go through it a little bit. First one is a NIR question. So how long does it take until an NIR system is ready and up for running, Andreas?
Yeah, good question. So basically, the installation of an NIR instrument is very easy because you just plug in the power and you start it, and after warming up, you are ready to go. Of course, an NIR is a secondary technology, so secondary method, so you need to calibrate. But our systems come with a lot of pre-calibrations. So for a lot of main products, it's easily done, maybe with a bias correction. Or when you have special recipes, special products, you may have to add products, and you have to, of course, validate the methods then. Yeah, but this is a matter of days or a few weeks until you have all the samples. Yeah, it's more the matter of the samples.
Sounds good. Next question here. How does NIR accuracy compare to reference values?
As I said, NIR needs to be calibrated, and in principle you can say that we match the accuracy of the reference methods. Of course, transferring the values has some errors, yeah, but on the other hand, NIR is so simple to use, and operational error is very low because anybody can do the sampling and the measurements. So that helps to be reproducible and helps to be accurate in the end.
Okay. And then we have here another one, also going direction NIR. All the sample types that have been measured, is it also possible to measure those online, inline?
Yes, yeah, we have a dedicated product line for process analyzers, so we can measure liquids, solid samples, semi-solids, all kind of samples inline or online. Yeah. So that's a broad portfolio, and we have a lot of experience in that. So just come back to us and we can talk about it.
Sounds great. The next couple of questions are now rather for me, so it's XRF questions, it seems. So one question that came up is about heavy metals in foodstuff and also about soils. Is that a topic for XRF? Long story short, yes, XRF can also determine heavy metals. Detection limits are somewhat at the low ppm or sometimes sub ppm level. It's something where you would definitely calibrate based on matrix, so you would have a calibration for certain foodstuff or for certain soil types. Then how much calibration work needs to be done is another question here, and do I need to recalibrate the instrument? So calibration, I showed a little bit rather during the presentation, is relatively straightforward. Of course, a little bit like FT-NIR, we need references, reference values, reference samples to calibrate the instrument. But it's a matter, if you have the samples of rather hours, maybe some tweaking, then you have a day, some testing. And then later on, the calibration can be used throughout, can even be extended later on, so you don't need to recalibrate. Okay, another question that came here up is a bit a mixed question for XRF and sample preparation. So here it's about meat analysis, and if XRF is also technology to measure the bone content. So this is something that came up a bit more recently. We don't measure the bone content as the bone, but we can measure the calcium content. And so the residual calcium content is something that we can determine with XRF, and by that basically determine the bone content in processed meat materials. For example, minced chicken or beef, for example. About how to prepare the sample, that would be more a question for Gerhard here. Okay, so maybe you can help us here.
Yeah, well, preparing of meat is quite easy with a knife mill. So it's not that you can create a defined fineness with meat, but you can homogenize the sample quite easily with a knife mill to a paste like, yeah. Mm-hmm. So all the if there's any bone in it, it will be homogenized and will be mixed completely with the samples. You get a good average.
It's distributed.
Yeah, it's distributed in the sample. So that's what we can do with a knife mill. Very good. Yeah.
Okay, sounds good. So there are a few more other questions that our host has picked here for preparation. The one is more about ball mill. How can I remove sticky material from the jar or the balls? What's what to do?
This happens quite frequently when you've got soft materials and you start grinding by impact, that the material sticks to the jar and walls and balls. And yeah, cleaning of the jar is always sometimes an issue. Don't scratch it off with a spoon or something like that. We normally just use quartz, sand, or glass, and we grind the sample. We grind the jar, and then it's clean afterwards. So you just wrap it off with the sand. Then it's normally easy to clean it afterwards with rinsed water.
Yeah, sounds pretty much straightforward, I guess. Another one here on the screen is like, is it possible to grind oily samples like grape seed or mustard into a powder? Is that tricky?
Yeah, sometimes. Yeah, the problem is with the oil content in the sample. So when you start grinding, you release all the oil, and then the material starts to stick. Yeah. In this case, we normally use with ultracentrifugal mill, we use distance sieves. So the sample is not actively pushed through the sieve, but just on its own acceleration. So it's not that aggressive grinding. So it can keep the oil inside the sample and do not release it completely. Yeah. So to a certain extent, you can create powders with that.
Yeah. So it requires a bit more thinking here.
Yeah.
And then maybe the last question, also from a timing perspective, to wrap it up. Can the knife mill be cooled that you have?
Yeah, the knife mill itself, not, but we can create something like cryogenic grindings in a knife mill. Then we use, you have seen the polycarbonate jar, which is not used for cryogenic grinding, but we can use a stainless steel jar and add some dry ice in that. And then you can actively cool the sample during grinding, so it stays cold, and you don't release or volatile matter, or also you can keep the sample cold and brittle inside the jar. So then it's also useful to cool the sample.
Yeah, excellent.
It's possible.
So I think with that, I would like to wrap it up. There are still a couple more questions even coming in, and we have also received some questions beforehand. So we will summarize that with a delivery package afterwards, together with the recording and the slides, which will also be distributed. So I thank you very much for your time, your interest in this webinar, combined RETSCH and BRUKER, combined different technologies. I hope you enjoyed it. And from my side, I wish you a great day.
Thank you.
Thank you very much.